Welcome to our Thursday Tech Spark. My name is Tao. I'm an account manager here at Meanwell. And today I'm joined with Brian, our technical sales manager.
Hi, my name is Brian. I'm engineering manager at Meanwell USA. Today we're going to go over some interesting industry, for industry that we have with our customer in the past.
Yeah, and for those of you who are not familiar with our 3+N systems, the 3 stands for rack power, modular power, and also systems power. And the N represents the infinite possibilities of our products, combinations, and flexibility. So our team can help recommend and also propose a set of flexible and direct solutions which can be assembled and adjusted according to the customer's application requirements. So as Ryan said, today we'll be walking through 4 different application examples from 2024.
Yeah, so this 4 industry is what we want to share today, and all these 4 industry are using Meanwell 3+N product, whether they are high power like an SXP series, NMP modular power, or the rack power. It will be a very interesting application of case sharing.
Yeah, let's go ahead and get started. First, let's talk about the hydrogen industry. It's a fuel that's been around for decades, but now making its big waves into clean energy. It's very lightweight, versatile, and when produced correctly, it creates 0 emissions, making it a key player in sustainable and green energy, which is actually one of our focus industries for 2025. And in 2024 alone, the global hydrogen market actually is worth $262 billion, and demand continues to keep growing. A lot of countries and companies are actually pushing to make hydrogen more affordable and widely available. And innovations and investments are moving fast, making hydrogen a big part of our energy future. So Brian, can you share a little bit about this application case?
Okay. About hydrogen industry, like Tao just shared, there are many ways to, other than that, there are many ways to make hydrogen. Typically, it's done by natural gas. And the second one is by electricity, and then the third one is what is called green hydrogen. But for this particular application for this customer is that they want to generate high amount of hydrogen on site. And for application, what is it used for? The hydrogen will be used for the metal purification or fertilizer, ammonia fertilizer. So the entire system, the electrolyzer stack or the electrolyzer stack and the power supply will be inside one of the large container delivered to the site to generate hydrogen and will be used on site. The main reason is that hydrogen, the cost to storage and deliver is high. That's why this customer want to deliver another alternate solution. Claiming that it's going to be cost lower for the end user. And so the customer decided the electrolyzer, they need like a 2000 amp current to drive the electrolyzer. And electrolyzer application or hydrogen is it's like a battery bank. It's basically forcing the power supply in a constant current mode, and then slowly charge up. And the unit will, the power supply always stay in the constant current mode. So with 2000 amp and 55 volt demand for one stack, like 100 kW. So we suggest to use the system power where we put a unit SXP 30K inside a 30U rack. And we also have the CMU2 installed on the top, like I showed in the photo, because the customer want to use the CMU2 to control the power supply voltage and current while it's charging up the stack. So the power supply SXP 10K communicate with the CMU2 by the CAN. And the customer use the computer you see on the screen on top of the rack to send the Modbus command to control the power supply voltage and current to charge the stack. And so by doing so, they are able to force the power supply in the constant current mode and without shutting it down. And so you also see, there's an exhaust lot. That's typically how customer use the system power, they usually want to have some extra spot, okay, for them to put their own like UPS people, computer into the same rack. So that's why you see in the middle, you see two black slots. Those are the UPS, okay, the UPS, AC UPS, where the customer need to have 24-hour on site to control the stack, the stack and the power supply in case there's a power outage. Okay, that's why you see those. You see the computer and the monitor on the top. It's to control the power supply.
I'm also curious, Brian, because I see that the power requirements is showing two different power requirements, the 55-volt DC and then the 300. Can you kind of tell us more about why there are two different power requirements and why we suggested the SHP 30K?
Yeah, so at first, I mean, the customer demand like 2,100 kilowatt power, so we need to have we need to go with three-phase power, like 480 volt. That we have for the HXP available for the HXP, and also efficiency. Okay, efficiency is very important for the project for hydrogen generation, because it's got to be better than natural gas. It's got to be better than the other way to make hydrogen. So that's why the customer need to have the power supply that really high efficiency. Okay, the XP with the 55 volt, it can go up to 95% already. Okay, that's very high. And in the later development, the customer also gonna go with a higher power stack, meaning like they're gonna do like a 1 megawatt power. Okay, using but they're gonna boost the voltage to 300 volt. Okay, so in that case, we will have to offer the 380 volt for up to HXP 30K. Okay, so that is even higher efficiency, up to 97%. That's gonna make the overall efficiency of the system up to like 80%. Okay, so that is it's gonna be a good selling point. Okay, to the customer, to the end user, and so this is just electrical using electrical power to decompose the water to generate hydrogen. There is another application. All the customer, or as I know, they also use what is called green energy or green hydrogen. They call it green hydrogen because they use solar panel. Okay, they use solar farm to generate the power. Okay, and the power you need a DC to DC converter to drive the electrolyzer stack. So that what is called really green, because the energy it come from solar or come from turbine. Okay, to generate hydrogen. So that's the term. That's why they call green hydrogen. What we're doing right now with natural gas or with electricity is called gray hydrogen. But for this particular application, like I say, just is for on-site use, like high volume on-site use. That's why the entire application is going through the like a container delivered on-site. So when the customer need them, end user need them, they will turn on and use them. Okay, like for example, when they have to do the metal purification, then they do it, then they will turn it on. And they don't need them, they would just turn it off.
I see. No, yeah, thank you so much for sharing the system power solution, Brian. We'll go ahead and move on to our next application case for the industrial automations and robotics industry. It's actually two sectors that are transforming how businesses operate every day. And as of 2024, the market was valued at $233 billion, and it can be used, from factories to warehouses. This type of technology can make processes faster, safer, and more efficient, helping increase productivity, reducing human error, and basically can work around the clock without breaks, keeping workers safer and improving, overall efficiency. This in turn allows businesses to scale really quickly, adjust for demands, and also reduces costs. And the demand for robotics is only growing, driven by industries like e-commerce, automotive, and then healthcare as well too. So Brian, can you kind of walk us through this modular power solutions?
Yeah. So this one is more for manufacturing or industrial automation instead of the robotic. Okay. It's so for this application, it's basically to clean the fiber optic connector. because fiber optic is go very long distance, and is the connector when it get like oil or dust on it, even when human eye won't see it, okay, it will affect the data transfer. You will have data loss. Okay, when the connector gets contaminated by oil or dust, it will create a data loss or cause a offline issue. That's why fiber optic connector usually need to be cleaned, but scheduled clean or before they use, they need to be cleaned thoroughly. There are many ways to clean it. Either by manual, okay, you can manually cleaning it, but it's gonna consume a lot of time. And so this customer, they developed a automatic cleaner to clean the connector and also inspect the connector after they clean it. Okay, so they come to us, I mean, because they have been using many different 4 or 5 different power supply to power the elements inside the cleaner, and they want to consolidate them into one single unit. Okay, to lower the installation cost, inventory control, to buy one power supply from this vendor, another power supply from another vendor. So we suggest the NMP, okay, where they have 4 output voltage, okay, and the 48 volt, the customer use the equipment is used to power like 17 motor together, okay, 48 volt as 600 watt to power the motor, and the motor mainly is to use for cleaning purpose, okay, move the connector in place, and then the 20 volt is used to power the computer to control the cleaning process. Okay, and the 5 volt is basically for visual, okay, to to check the cleaning process. Okay, and the 12 volt is just for auxiliary. They use to power the fan and also some interlock. Okay, so with this solution is able to help the customer lower the installation cost, and also one single power supply that power all basically. And another feature is the customer want, like the power NMP, is that they have the local and global enable, where they can locally turn off and 48 volt if they don't need the to do the cleaning, and then when they need to do the visual only, they turn on the 5 volt, or when the unit is in the standby mode, it's just turn off the all for all. Okay.
Yeah. Thanks, Ryan, for kind of going through this like really cool fiber optic cleaner inspection. And I do want to add on, for those of you who don't know, we also have a selection tool on our Mimo websites. If you guys are using the MMP series, to help select the configurable power supplies based on your customer's requirements. And let's go ahead and move on to the energy storage industry. Plays a big, crucial role in the transition to renewable energy. And energy storage allows us to store, the excess energy for later use. Within just 2024 alone, the global market was valued at, $220 billion, which is why, it continues to keep growing. And why is the energy storage important? First is, grid stability. It helps balance supply and demand, ensuring that, reliable power grid is used as a renewable source energy grows. And renewable integration as well too. So it helps stores, excess solar and wind energy for when generation is very low. And third is cost efficiency. It helps reduce, your electricity costs by storing energy during these like off-peak hours. And the market for the energy storage is set to expand really fast as we are continuing to see improvements in the battery technologies, as well as government policies continue to really support these clean energy adoptions, as well as we move towards a more renewable power world. Energy storage will be more essential in ensuring power reliability as well as reducing emissions. And then Ryan, I'll kind of let you take it away with this application.
Yeah, so energy storage industry is have been going on for like 4 to 5 years, but it's still going, mainly because it help utility to not to build or invest into more power plant, and because this energy storage is usually in like a container, very big 27-feet container. A lot of them underneath the grid, power grid. It basically everyone know is for peak power saving. So when 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 the power demand high, the battery will act as a power sharing to support the peak load, and when the demand is lower, it's used to charge and recharge the battery. So by doing so, utility company they don't have to really invest too much into the power plant or make the world much greener. Okay, this way. So for this particular application, or usually for battery energy storage, for this application, it always has a what is called a UPS. Okay, UPS system to power the BMS, the battery management system, because developing the energy storage, a company making the energy storage usually have to do a software where it be able to monitor and control the battery, the energy consumption. So that software need to be on 24 hours. That's where the BMS is doing. Okay, so in order to have the BMS on 24 hours, the customer develop their own UPS. Okay, some purchase like an off-the-shelf AC to DC, AC to AC UPS, but this customer they chose to design their own AC UPS. They use the true RCP 1624, trim the voltage to 26.5 volt by the CAN bus to charge the battery, and then the battery would also power an inverter, which is also the NTS 2200. Okay, the NTS 2200 then will power the battery management system. Okay, so when there's a power outage, okay, the battery, the 150 mAh battery will power the inverter supporting the BMS, so that they're able to continue to monitor the energy. Okay. And so on the slide, you also see there is a PV, PC, and CAN bus redundancy. Okay, why is there? Because the customer want to help the control charging and voltage by either or. Okay, meaning that for example, if the CAN bus is down or someone unplugged the CAN bus connector and didn't plug it back, then the PV and PC would also kick in. Okay, so that it's not going to overcharge the battery or over voltage the battery. Okay, then in other words, it's basically a redundancy. When the CAN bus is lost, the PV and PC will be able to kick in and help to control the charging. So in summary, this application is it's just the UPS. You will see them when you approach the customer with energy storage application. They always have the UPS. Okay, they either design their own or they have to purchase off-the-shelf UPS. But for this particular customer, they chose to design their own BMS and design their own UPS to power the BMS.
Gotcha. Yeah, no, I was curious too, because I saw, I know CAN bus can help, the protocol can adjust voltage and current as well. So I was also curious why we would need a PV and PC redundancy. So thank you.
Yeah.
For kind of going
I mean, beside the true RCP 1600, the customer basically use 4 in one rack. They in case it's one RCP 1600 malfunction, and then they have another one to kick in. I mean, because they're able to use the CAN to control the charging current. The battery is like 150 amp, and then they use like 100 amp to charge the battery. So within like 1 hour and a half, the battery will be fully charged.
Gotcha. Oh, yeah. And then we'll go ahead and move on to our last and final application case. This one's going to be the portable generator industry. And this market plays a big role in backup power solutions, as well as outdoor activities and off-grid applications. Where is the industry today, right? The global portable generator market valued at $4.9 billion within 2024, and still projected to grow steadily, with key drivers like increasing power outages, natural disasters, and really a rising demand for reliable off-grid. And then here we have the rack power solutions for a charger for a portable generator. And Brian, can you kind of walk us through how we're able to provide the solution and kind of customer requirement and everything? Yeah.
Okay. So let me go over the application first. It is for a portable generator, but it's like for a hybrid type. where it's like it use fuel, okay, to power the generator and then to charge the battery. And when the battery is fully charged, okay, the battery would invert. Okay, it's gonna use the power to supply the inverter. So you see, the generator basically there's an inverter. The customer design their own inverter. Okay, so when the battery is fully charged, it's basically going to inverting mode. The output power. Okay, so for this application, the customer need like a 10K watt, 57 volt and to charge the battery. Okay, when the battery is full charge, then it's be able to use at the inverter to provide power to the inverter. And this generator usually used at the remote site, okay, or it can also be used as a backup for house backup as well. It isn't that big. Okay, there's like more like 100 kilowatt of generator, but this one, the size is not that high power. Okay, it's like only like 8 kilowatt power. And because the design here is that the customer want to target two application. One is remote side, the other one is for home use. Okay, so the inverter that is being designed here is that it can also be used at the grid time. Okay, so when for example a power outage, okay, the battery fully charged, it can be the inverter can supply power to the entire house as well. So that is for backup use. And when offsite use is like the fuel will basically charge power up the rack, the NCP 3200 to charge the battery, and the battery would also will power the inverter. Okay, so that how this hybrid generator is used for this particular case, because there's a lot of portable generator, but there are a lot of them that fuse. But this one, the new design is that they use a battery built-in battery bank, so that it can be targeted in the market is for like backup home use.
I see. Actually, I was gonna mention, because this application really looks similar to one of our other ones for the EV charging application using the NTN 5K. Can we also use the NTN 5K with
Yes.
this application as well?
Yeah, some other from other application, other customer use the NTN 5K. It basically because the NTN 5K is it has charging built-in and also have inverted function built-in. Okay, but for this particular customer, because they want it to be grid tied, so they designed the inverter, their own inverter, so that it can use it grid tied. But for EV charging application, a lot of customer it usually use the NTN because it serves the cost. Because the NTN has the charging function built in, and then it also have act as an inverter. Okay, it's like a combine of charging and inverting function. Instead, they have to spend time and money to design the inverter unless they really need the grid tie. Okay, the NTN 5K doesn't do any grid tie, but it can support like high power. It can do like a single phase, a dual phase output, or even three phase, wide configuration output to for backup generator.
Gotcha. Okay, and then that takes us to the end, concluding, our 3+N applications for today. I hope you guys all found it, this TechSpark informative and have a better understanding of what we can offer in terms of, system solutions, and kind of keep this in mind when you guys are, talking to your customers. And I just want to mention, by selling these system solutions, you're not just providing a product like a power supply, but you're able to solve a bigger problem for your customers. And this leads to higher retention, stickiness, really great revenue potential, as well as a strong competitive edge. And I do want to remind you guys that we do have our product seminar on March 13th from 4:30 to 6:30 Pacific time, and that's going to be 7:30 to 9:30 Eastern time. And we hope you guys can all make it, and we'll see you there. That kind of concludes our Tech Spark for today. Please, if you guys have any questions, don't hesitate to reach out to Brian here or our team, Kareem and Han as well. That kind of wraps up all for today. Thank you, Brian, and thank you, everyone.
Thank you, everyone. Hope you guys like it. Okay.
Bye.